Our goal with this problem is to be able to find the x-intercepts, the axis of symmetry, and the vertex so that we complete the graph. If we notice the graph, the original equation is given to us in standard form, and that the a value right there is a positive 1. And so therefore, I already know that this parabola does open up. If we use the zero product property to take each one of our factors and set those equal to 0, we can see that at -1 and at -5, we're going to have our x-intercepts or our roots, our solutions, our zeros to this parabola. So I'm going to take a minute, and at -1, 0, I'm going to place that in on the graph there, and at -5, 0. If I know that my x-intercept is here at -1 and here at -5, I know that the axis of symmetry must be between these 2 points. And so I can take and find where that middle point is by taking the x coordinates and adding them together and dividing by 2. That's going to tell me that my axis of symmetry is the line x equals -3. It also tells me that the x coordinate of my vertex is at -3. And so now I could take and put in the axis of symmetry . I still need to find the y coordinate of my vertex. So if I go back to the original equation that was given to me, and if I know the x value is -3, I can find the corresponding y value by substituting -3 for x in the original equation. And so that gives me a y value of -4. I now know the y coordinate of my vertex. I can now take and place my vertex at -3, -4. Okay. That would make my vertex a minimum value. If I now take my pencil here, marker for me, and put my vertex right there on, or put my tip right on the vertex, I can now count over 1 squared, I move up 1, go back to the vertex, I can move to the right 2 squared is 4, there's my other, another point, which is also the intercept. I could go back to the vertex, I can count to the right 3 squared is 9, if I move up 9, and use symmetry to fill in the other point, I can see that I now have my parabola that I could take and draw that U-shaped curve.